Hello and welcome to December 18th. We're sitting about 3 days before the winter solstice, and you can see that our sun rays are coming in at a very small angle. I've actually moved this guy to be 38.1. Actually, it looks like 38.38. Well, we're going to keep him at 3. 38 degrees, which is latitude for Dumfries, Virginia, and you can actually see it's right there. Now, it's also Fairfax where I am or Woodbridge where I teach, but this is the latitude for our school and where I live. Okay, so he's sitting, looks like about 12, sitting right smack in the middle of the line. You can see the line that he's on actually has mostly dark. That's because we're 3 days away from the shortest day of the year. So as the Earth rotates, as this person stays there, they spend more time in the night than they do in the day. We'll have about 9 hours of daylight and about 15 hours of darkness. If you take a look, you can see that the North Pole is not seeing it. As the Earth rotates around, the North Pole will not see the sun at all. South Pole is 24 hours of daylight, and the North Pole will actually in 3 days get its longest darkness, and the South Pole will get its longest lightness, if that makes any sense. If I throw in some labels here, okay, so we have the autumnal equinox going this way, the vernal equinox going that way. This is the winter solstice, and this is to the summer solstice. And this only works because this is maybe coming from, and I have no idea what it's talking about, but this is the winter solstice, and this is the summer solstice. So what I can do is I can actually move this, and if you take a look, we got 23.4 degrees, which is about the maximum low level of the sun. If I throw it to the celestial sphere, you can see the sun is about as low as it's going to get, but I can move this sun, trying to see if I can get anything bigger than 23.3. There's 23.4. Looks like 24, and we're sitting at December. Actually, it looks like we're still sitting on. So today it's going to go from 3 to 4, and then that's the largest one. I teach the kids it's 23.5 degrees, but it's really 23.4 something. And then if you go to December 21st, right here, this is our shortest day of the year. If you watch this line right here, I'm going to move it around, and you can see that line changes. There we get 12 hours of day and 12 hours of light. That was the autumnal equinox back on September. They're saying September, if I can get it in the middle, looks like I can, but somewhere around September 19th, 20th. Don't remember exactly. And then we move it over here. We can get the winter solstice, and then we can move it over here. That's going to be our spring solstice, and we're back up to 12 hours of daylight and 12 hours of night. And if I move it this direction and move it over to 23.4. Looks like we're sitting around June 22nd, June 21st, the longest day of the year. And you notice the difference between as this person's going around, we only have 9 hours of night and 15 hours of daylight. And if you notice the sun rays, they're coming more direct. You really don't get any direct sunlight unless you can move this person to the Tropic of Cancer. You can see they're straight up and down. And then we move to the equator. They're tilted about the same as they are here, except they're in the opposite direction from 38.1. There's 38.1. Okay, so if I move it back to this view, what I'm going to do now is I'm just going to start the animation. And you can see the Earth is going. I really wish this Earth would spin around. It is spinning in this direction, but it's not spinning in the rest. And if you watch these lines, you can see they're getting more and more tilted as we approach the vernal equinox. Right there. And then they tilt more and more and more as we're approaching the winter solstice. And you can see, and let me actually stop it when we get there, and I'll show you one other view. Okay, if I go to the sunbeam, sunbeam looks like, let me go back to here. You can see that's all nice and concentrated inside that one square. So we'll say this is 1 square of solar radiation. And you can see it gets more oblique. So we actually have an elliptical thing. It actually is reaching one, almost two squares, so the light's being spread out over a larger area. And because of that, what we get is we get the sun rays not as direct. And if we move back to there, you can see they're very low. Then we start the animation, and now we actually start seeing that they're getting more direct. And they're moving closer and closer and closer to vertice when we actually get to this vernal equinox over here. They're about midpoint. And then as we approach the summer solstice over in this direction, they're going to get as direct as they can get. And I'll stop it when we get to about there, June 21st-ish. Okay, and if I take a look at that same angle, you can see the angle is much tighter. So we get more direct solar radiation, which is one of the reasons we actually get warmer temperatures in the summer than we do in the winter. The other reason is we get a lot more sun rays and we spend more time in the sun. So our days are longer. So it warms up, more direct, and that's basically why we have seasons. Okay, I will copy this link and I will put it in the comments for this video. Thank you. Bye.